There's a trig equation to solve here between 0 and 2 pi, and this is the nice one. So, how can we deal with this? Well, what's jumping out at me is to use addition formulae. Sine A minus B, like expand it. There's nothing we can do at the moment with this not being the same as this. Okay, so that's one to know. Therefore, in our case, we have that sine pi over 3 cos theta minus sine theta um, cos pi over 3 is equal to 1 over 3 cos theta. Now, sine of pi over 3 is going to be it's going to be root 3 over 2. That's one to learn. It's the same as sine 60. Whilst cos pi over 3, same as cos 60, is a half. I'm gonna do two things in one go. So I'm gonna put these numbers in and I'm gonna minus the right hand side. So 1 over root 3 cos theta, and then add on a half sine theta. Then I can bring this together into a single cos function. Sorry, I think I said it, but that should have been an equals. I'm also going to multiply through by 2, so that I've got a 2 over here. Now this is in a good form because I can divide through by cos, so I get that tan theta is equal to, now this doesn't look nice, but I got a feeling it's going to sort itself out. I'm going to times through by that 2, so I'll get root 3 minus 2 over root 3. Okay, so I've just times this left hand one by 2 and this right hand one by 2, divided through by cos, put this over common denominator, we're going to get 3 minus 2 all over root 3, because root 3 is the same as 3 over root 3, which is just 1 over root 3, which is brilliant, because that is equal to, that's one to know as well, pi over 6. We're interested in between 0 and 2 pi. So I've just found this first one here, pi over 6, and then, which is the same as 30 degrees, by the way, if you like to think in terms of degrees, and then we can add on 180 or pi, so we're also going to get 7 pi over 6. And those are our two answers to this question. Let's take a look at B. I always like to write sine to -1. Like, I understand it can be a bit confusing because you might think it's 1 over, but we're hopefully familiar enough with it. I'm just going to write it like that. My temptation then is like we have inverse signs. We need to basically undo it. And so what we can do is take sine of both sides. Like this is an equation, so there's nothing stopping me doing that. And the only issue is that I've now got sine of this whole thing here. And remember, I can't do them separately. I'm going to need to use addition formula again. That's going to cancel. So it's going to be, we can use the same addition formula as above. It's going to be sine pi over 3 cos inverse sine, and then it's minus sine. So I'm going to do the minus down here, otherwise I won't have enough room. Sine of inverse sine times cos of pi over 3. The only issue here is this thing, this cos of inverse sine. Now, if you've done lots of these sorts of papers, you will hopefully be familiar with how to deal with that. If not, I will be going through it. 1 minus 2x will equal sine pi over 3. Remember that was root 3 over 2. Okay, now cos of inverse sine. Well, sine squared is 1 minus cos squared. I don't know why I wrote it like that. Cos squared is 1 minus sine squared. That's what I meant to write. Which means that cos is basically the square root of 1 minus sine. And that's how we can go from cos back to sine. We can write that it's going to be 1 minus sine of inverse sine all squared. And that's going to give me x squared. I'll just show that in a little bit more detail here. So cos of inverse sine x will equal or be equivalent to 1 minus sine of inverse sine x. And then it's squared, but actually technically we do that first and then we square it. That's what the square means. And this thing here is just x. I'm just trying to explain where that just came from. This next one will just be x here, sine of inverse sine. And cos of pi over 3 is a half, so it'll be minus a half x. Still lots to do. I've got a square root in there. It's a bit of an issue. First thing we can do is, I'm tempted to times through by 2. 2 minus 4x equals root 3, 1 minus x squared minus x. And then I'll add x onto both sides. So this will disappear and this will become 3. Now I've got everything, like I've got something all right on the left-hand side and I've got a square root by itself, not minusing something. I don't want to be dealing with that. I can now basically square both sides. I didn't want to do it here because you get like awkward terms overlapping. We've got to get it on one side first. So it's going to be 2 minus 3x all squared will equal 3, 1 minus x squared. I can square the root 3 and I can square this square root. That's going to give me 9x squared minus 12x plus 4 equals 3 minus 3x squared. 12x squared minus 12x plus 1 is equal to 0. It's tempting, and like I always say, the first thing you should do is try to factorize this. But it won't actually factorize. You can't get, if you got the plus 1 and a minus here, then you would have to have a minus 1 and then minus 1. That's the only way it's going to factorize nicely. But whatever you put in, like if you put 12 and just 12x and an x, no, you're not going to get minus 12x. If you put 6 and 2, that's not going to work. 4 and 3 won't work either, so it won't factorize. We're going to have to use quadratic formula. I just want to say one other thing at this point. We had to square the equation, so we may have introduced extra solutions. We just need to be really careful. Sorry, moving around a lot there. We know that x has to be between 0 and 0.5. So it's minus b plus or minus b squared minus 4ac all over 2a. Then we can try to um, simplify this root 96 down. Think about what goes into it. 4 is going to go into it. 4 times 24. That's right, isn't it? But then 4 goes into that. So actually we're going to get 16 times 6. And that's going to be the largest square number. So I can write it as 4 root 6 over 24. And then divide through by the common factor of 4. 3 plus or minus root 6 over 6. Quite like that. Now, we need to think about this. We have the x has to be between 0 and 0.5. Root 6 is going to be less than 3. Um, so it's never going to become, this isn't going to become negative, is what I'm trying to say. But also, if I have 3 plus root 6 over 6, well, this is 3 over root 6 is already a half. So this is greater than 0.5. So reject. And we do just have one solution. I think we can be pretty sure that's not going to be a spurious solution. When we squared it, we didn't actually introduce any extra ones here because we had a squared here already. So we're okay. I did mention that, but we'll be okay. So finally, x is going to equal 3 minus root 6 over 6. And I think that's a pretty good way to leave it. You could write it as a half minus 1 over root 6. When I originally did the problem, that's how I left it. But actually, I think it's pretty decent like this. Brilliant.